Welcome back. This is Ahmed Awad. In this video, I gonna learn you how to factor a special product. It's the opposite of which we did in lesson 4. In that lesson, we learned how to get the product of sum and difference like a plus b multiply a minus b. As you know, the product of these two factors will be the first square minus second square. And we also learned how to find the product square of sum or difference like a plus b all to the power of 2 and a minus b all to the power of 2. And the product of this one will be the first square plus 2 multiply first multiply second plus the second square. And this one, it will be first square minus 2 multiply first multiply second plus the second square. This is how to find the product called perfect square trinomial. And I ask you to factorize, and it's our second objective. Let's start our first objective. Factor difference of squares. It's very easy and very simple lesson. If we have any binomial in form of a to the power of 2 minus b to the power of 2, the first one must be perfect square, which is any base can be written as the form a to the power of b, a to the power of 2. And the second one also must be perfect square. So, to call the binomial its difference between two squares, it must be in the form of a to the power of 2 minus b to the power of 2. It's directly factorized as a plus b multiply a minus b. As if I give you 4 minus x squared. So 4 is perfect square. Why? Because we can write it as 2 to the power of 2 minus x to the power of 2. It's already perfect square because it's x to the power of 2. So directly we write it as 2 plus x multiply 2 minus x. As this example. Example number 1, factor difference of square. 16h to the power of 2 minus 9a to the power of 2. First step, you must check, is it difference between two squares or not? If the first one can be written as base to the power of 2, yes, 16 is perfect square. We can write it as 4h to the power of 2. And the second one, is 9a to the power of 2. Also 9 is perfect square, so we can write it as 3a all to the power of 2. So here we have difference between two squares. So it's directly factorized as what? 4h minus 3a all multiply 4h plus 3a. We can reorder them. We can write it first plus and second minus, or first minus second plus. Okay. Another example, 4a to the power of 2 minus 25. Okay guys, again, is it difference between two squares or not? The first term is 4a squared. It can be written as 2a all to the power of 2. And second one, 25, can be written as what? 5 to the power of 2. So it's yes, difference between two squares. So directly it would be factorized as the product of two polynomials. The first one is 2a plus 5, and the second one is 2a minus 5. If you understand, please go and solve the exercise which are shared in the discussion room. Second objective, factor perfect square trinomial. First, what is a perfect square trinomial? From its name, it's trinomial, so it's consisted of 3 terms. The first one must be perfect square as a to the power of 2. The last term is p to the power of 2, also perfect square, and it's always positive. And the middle term can be positive or negative. 2 multiply the square root of the first term, which is a, and the square root of the third term, which is b. So any expression written in this form, a to the power of 2 plus or minus 2ab plus b to the power of 2, it's called perfect square trinomial. And this trinomial is factorized as one binomial a plus or minus b to the power of 2, or we can say this trinomial is factorized as the square of plus or minus or sum or difference. Now let's use it. Example number 2, recognize and factor perfect square trinomial. The question here is to determine whether each trinomial is perfect square trinomial, yes or no. If so, factor it. So first step, we must determine is it perfect square or not. To determine whether is it perfect square or not, we must answer these 3 questions. The first one, is the first term is perfect square? Here, what is the first term? It's 4y to the power of 2. 4y to the power of 2. It can be written as 2y all to the power of 2. So yes, it's perfect square. What about the third term? Is it perfect square? 9? Yes, 9 is perfect square. Why? Because we can write it as 3 to the power of 2. Okay, now let's check the middle term. Is the middle term is 2 multiply 2y multiply 3y? Let's check. 2 multiply 2y multiply 3. What we get? 2 multiply 2, 4 multiply 3, we get 12y. So the given trinomial is perfect trinomial. So directly we can write it as what? A plus b to the power of 2. Okay, here why I choose plus? Because here the middle term is positive. So it would be what? What is the first term? 4y to the power of 2. So it's 2y. The square root of it, it's 2y. Plus the third term is 3 all to the power of 2. Now let's move to example number 2. 9x squared minus 6x plus 4. First, if the first term is perfect square, 9x squared, yes, it's perfect square. We can write it as 3x all to the power of 2. What about the third term? Is it perfect square? 4, yes, 4 is perfect square. It's 2 to the power of 2. Now, is the middle term is 2 multiply the first multiply the last? Let's check. Negative 2 multiply 3x multiply 2, we get 2 multiply 3, 6 multiply 2, 12. So we get negative 12x. So, and the middle term is what? Negative 6x. So this trinomial is not perfect square. Okay, let's make it more clear and solve another example. 25x squared plus 60x plus 36. Okay, let's first check the answer of the 3 questions. is the first term is perfect square. 25 x to the power of 2, it's perfect square. Why? Because it can be written as 5x all to the power of 2. What about the third term? 36 is the perfect square? Yes, because it's a product of 6 and itself, so it can be written as 6 to the power of 2. Now, is the middle term is 2 multiply 5x multiply 6? Let's see. 2 multiply 5, 10 multiply 6, we get 60x, so it's also done. So this trinomial is, yes, perfect square trinomial. Okay. Now, so we can factorize it as what? As the square power of 5x plus 6. And why it's plus? Because the middle term here is positive. Okay, another example. 25x squared minus 20xy plus 4y squared. First, we will answer the 3 questions. If the first one is perfect square, 25x to the power of 2, yes, it's perfect square. It can be written as 5x all to the power of 2. And the last term, 4y square, is it perfect square? The answer is also yes, because it can be written as 2y all to the power of 2. Now, is the product of the first term after the square root and the square root of the last term multiplied by 2, we get the middle term. Let's check. 2 multiply 5x multiply 2y. What we get? 2 multiply 5, 10 multiply 2, 20. X multiply y, we get xy. And it will be negative 2 multiply this sum, because the middle term here has a negative sign. So it's the answer here is what? Is yes, perfect square trinomial. So it directly is square of difference, because the middle term here is difference between what? Between the square root of the first, which is 5x, and the square root of the third, which is 2y. And you can also check to get the product and see if you have a right answer or not. You can use your book page 543, okay, and solve exercise 1 and exercise 2. I hope you enjoy this lesson, and good luck. Bye.